Okay guys, so in this video we are going to talk about translating from vertex form into standard form. So we've been dealing with this form so far this year, but actually most quadratics are given in this form, standard form, which we actually saw at the beginning of the year in Unit 2. So we're going to talk about how do we get from vertex form to standard form, and how do we end up graphing standard form, since we've only been graphing in the first form. So let's say you're given the function f of x equals 3 times x plus 2 squared minus 8. We want to convert that into standard form, since that's actually the most common way of graphing or solving quadratics. So all we're going to do is follow PEMDAS, remembering that x plus 2 squared really means x plus 2 times x plus 2. So we can rewrite our equation like this. If you want, you can go off to the side and do box method, x plus 2 times x plus 2, or you could do the mailman method. And so if we do that, x times x is x squared. We'll bring down the 3. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And that's all still being multiplied by 3. So we combine like terms inside the parentheses. Oops, not squared, just 4x. And then we distribute the 3 inside the parentheses, multiplying each term by 3, giving us 3x squared plus 12x plus 12 minus 8. And then we combine those last like terms to give us this equation. And that's it. That's all you need to do to convert from vertex form to standard form. Something really important to notice that a, the stretch factor of 3, is still the same value in this equation. So a remains the same. That's why we called it a when we were in vertex form, because it stays the same. So a would be 3, b would be 12, and c would be 4, according to our standard form formula. So let's look how to graph this, keeping in mind that a is 2, b is 4, c is negative 7. We're just getting that from the coefficients of each term. So in order to find the vertex, we can't just look at the equation anymore like we were when we were in vertex form. You have to use this formula. The x-coordinate of the vertex is negative b divided by 2 times a. That's the formula to find the vertex, the x-coordinate of the vertex. So in this case, our vertex is going to be, the x-coordinate is going to be negative 4 divided by 2 times 2. So the x-coordinate of our vertex is negative 1 when we simplify it. So that's the x-coordinate of our vertex. To find the y-coordinate, we're going to just plug it into our equation. So we plug in negative 1, and we get 2 times negative 1 squared plus 4 times negative 1 minus 7. That's going to give us 2 minus 4 minus 7, which gives us negative 9. So the coordinate of our vertex is negative 1 comma negative 9. We got the x-coordinate by using this formula, and then we got the y-coordinate by plugging in the x value. And then for today, I'm going to show you a shortcut tomorrow, but for today, all we're going to do is plug in our vertex to a table and go 1 above and 1 below. If I plug in 0 to this function, I get out negative 7, which means that negative 2 will also give me negative 7 by symmetry. And then we're going to plot those 3 points. And that's going to give us our parabola. So that's how we graph functions that are given in standard form.